Hello everyone. So this is a question from JEE Advanced 2026 paper 2. In the following reaction sequence, major products X and Y are acyclic monomers. Okay, important. We have CH3I, it is subjected to 4 reagents and then we get X. Then we have caprolactam, then it is subjected to H3O plus and heat, then we get Y. 500 mole of X completely reacts with 500 moles of Y to give 1 mole of a single biodegradable acyclic copolymer Z as the only product. The amount of Z formed in grams is okay. So the chapters involved is haloalkanes and haloarenes, aldehydes and carboxylic acids and polymers. Okay. So to get X, we start with iodomethane, that is this guy. We are reacting it with the first reagent, that is potassium cyanide, KCN. Okay, so nucleophilic substitution reaction happens, that is Cn minus ion is replaced by I minus to give CH3C triple bond N. That is, with respect to reaction, I can write CH3I plus the first reagent KCN, we will get CH3CN, and this guy is known as ethane nitrile plus side product Ki. Okay, so here I minus is replaced by Cn minus. Nucleophilic substitution reaction happens. Okay, then CH3Cn is then reacted with this guy. It is reacted with the second reagent, that is H3O plus and heat. So nitriles are hydrolyzed to carboxylic acid in the presence of acids as catalyst. Okay, that is, with respect to reaction, CH3Cn, which is a nitrile, in the presence of H3O plus and heat, it is hydrolyzed to carboxylic acid, CH3COOH. Okay, and then we react CH3COOH with the third reagent, that is red phosphorus and Br2, which is the famous Hell-Volhard-Zelinsky reaction, where a hydrogen atom from the alpha position of the carboxylic acid is replaced by a halogen. Okay, that is, with respect to reaction, I can write CH3COOH. Let's say this is the alpha carbon. So I will be getting CH2 Br COOH. Okay, so in this, hydrogen atom from the alpha position is replaced by a halogen. Okay, so these guys in general are known as alpha bromo carboxylic acids. Okay, and when alpha bromo carboxylic acids are heated with the fourth reagent, that is NH3 excess, ammonia excess, we get alpha amino acids through a SN2 mechanism. Okay, that is, with respect to reaction, I can write CH2Br C double bond O OH in the presence of NH3 excess will give me CH2 NH2 C double bond O OH. Okay, so these are alpha amino acids because NH2 group is in the alpha carbon. Okay, and this is glycine. Okay, so therefore this is our X. To get Y, we start with caprolactam, okay, which is N connected to H and 1 2 3 1 2 3 C double bond O. So 1 2 3 4 5 6. Okay, so it's an example of cyclic amide. Okay, amide because you can see N is connected to a C double bond O linkage and it is cyclic in nature, so that's why it's an example of. So this guy is an example of cyclic amide. And caprolactam, that is this guy, is subjected to acidic hydrolysis and heat to get Y. Okay, When an amide is heated with an aqueous acid, that is, in general, this particular bond breaks, and this part of the amide will give me the corresponding carboxylic acid. So one of the product is going to be a carboxylic acid, and this part of the amide will give me the other product, that is the amine. Okay, so in the question we start with caprolactam, which is an example of a cyclic amide, which are also called lactams. Okay, important. Cyclic amides are also known as lactam lactams. Okay, hydrolysis of a cyclic lactam result in a linear amino acid. Very important. Okay, so whenever we have a cyclic amide and we do its hydrolysis, we will get a linear amino acid. Okay, so that is with respect to reaction. I will draw caprolactam again, NH. So it is undergoing hydrolysis, acidic hydrolysis, and heat. So this particular bond breaks, and here with NH we will have one extra H, and with this C double bond O we'll have an OH. Okay, so ultimately I will get NH. So this is what I'm going to get. Okay, so giving numbers to the carbon: 1, 2, 3, 4, 5, 6. Okay, so you can see this is a amino acid. Okay, and let's say this is the alpha carbon, beta carbon, gamma, delta, epsilon. So you can see NH2 group is on the epsilon carbon. So that's why these guys are also known as epsilon amino acid. Okay, okay, so this is our Y. So we have got X, which is glycine, CH2, C double bond O, OH, and NH2, and we have got Y. Okay, observe that both the reactants, that is X and Y, are bifunctional, that is they have two functional groups each. For example, in Y you have COOH group as well as the NH2 group. In X also you have the C double bond OH group and the NH2 group. Okay, so they undergo a series of condensation in a stepwise manner with the loss of a molecule of water at each step, leading ultimately to formation of a high molecular mass condensation polymer. Okay, so initially X and Y undergo condensation with loss of water to form a dimer. That dimer will combine with one more molecule to form a trimer. That trimer will combine with one more molecule of either X or Y to form a tetramer, and it goes on, and ultimately we get a very large molecule, which is our polymer. Okay, so I will write that down. Initially X and Y undergo condensation with loss of water to form a dimer. That is with respect to reaction, C double bond O, OH, 1, 2, 3, 4, 5, and NH. plus OH, C double bond O, CH2, and H2. Okay, so this is my Y, this is my X. So they will combine, resulting in a loss of a molecule of water, OH from here and H from here, and the new bond will be there between this NH and this carbon. Okay, so ultimately we will get a dimer, and the dimer will look like this. So we will have C double bond O, OH, and 1, 2, 3, 4, 5, and NH bond with C double bond O, CH2, and obviously a molecule of water. Okay, so this is the dimer that I was talking about. So you can see two molecules, that is one molecule of Y and one molecule of X combine with loss of one molecule of water. Okay, so I will write this down. This is very important. Two molecules combine with loss of one molecule of water. Okay, and if you see, observe carefully that this dimer is again a bifunctional compound. It has this functional group as well as, yeah, one second, I made a mistake, and the mistake is that I did not write the NH2 here. So you can see NH and C, there is a bond, yes, C double bond O, yes, CH2, and it should be connected to one NH2. Okay, cool. So yeah, so the point is that the dimer is again a bifunctional compound, because you can see there are, this is one functional group, this is another functional group. Okay, so it may react with another molecule of one of the monomers. It can be either X or Y. Let's say it reacts with X to form a trimer. Okay, so that is with respect to reaction I can write, so this is my dimer. So my dimer is C double bond OH, 5 carbon, NH, C double bond O, CH2. I will write NH2 in this fashion. Plus, let's say it combines with X, OH, C double bond O, CH2, and H2. Okay, so OH from here and H from here goes out in the form of a molecule of water, and then we get the trimer, and the trimer will look something like this: OH, C double bond O, C 3, 4, 5, NH, C double bond O, CH2, NH, C double bond O, CH2, NH2 plus H2. Okay, so this is the trimer. Okay, so you can see a trimer is formed by the combination of three molecules, right? We started with X and Y to get a dimer. Then we combined the dimer with one more X. So the trimer is because of the combination of three molecules. So three molecules combine with loss of total. How many water molecules? We have lost one here. We have lost one more here. So I can write three molecules combine with loss of two molecules of water. Okay, so if you see, the resulting trimer is again bifunctional. So this is one functional group, this is the other functional group. So it may react with another molecule of one of the monomers, can be either X or it can be Y, to form a tetramer. Okay, and it goes on. So the final polymer that we get is known as nylon 2, 6, because the monomers that we started with, that is X and Y. X has 2 carbon atoms, that's why nylon 2, and 6 because Y has 1, 2, 3, 4, 5, 6 carbon atoms. That's why the final polymer is known as nylon 2,6. Okay, and in the tetramer, the 4 molecules are going to combine. So for example, let's say trimer combined with one more molecule, so we'll get the tetramer. So there 4 molecules are going to combine with loss of 3 molecules, right? So in general, I can write n molecules combine with loss of n minus 1 molecules of water. Very important. Okay. So in the question, we have 500 moles of X and 500 moles of Y. Okay. So therefore, total 1000 moles of reactants. Okay. So these guys, these 1000 moles of reactants will combine with each other with loss of 999 moles of water. So these reactants combine with loss of 999 moles of water to give 1 mole of the polymer Z. Okay, so I got this because I have observed a pattern, a relation that n molecules combine with loss of n minus 1 molecules of water. So that's why 1000 moles of reactants will combine with 1000 minus 1, that is 999 moles of water. Okay, so therefore the mass of the final polymer Z will be equal to the mass of 1000 moles of reactants minus 999 moles of water, because we are losing this much amount of water. So I can write mass of Z as 500 into molar mass of X plus 500 into molar mass of Y minus 999 into molar mass of water, because we are losing this much moles of water. Okay, so molar mass of X will be, so 500 into we have 2 carbon atom 24, 5 hydrogen plus 1 nitrogen plus 2 oxygen plus 500 into molar mass of Y. So we have 6 carbon atoms, so 6 into 12 plus 13 hydrogen plus 2 oxygen plus 1 nitrogen minus 999 into 18. Molar mass of water is 18. Okay, so when you do this calculation, you will get the final answer as 85,018 gram. Okay, so therefore the amount of Z formed in grams is 85018 grams. Okay, thank you.